explain on that experiment that we can use to determine the specific heat capacities of different substances. Now in the method of mixtures, majorly we are going to use an instrument we refer to as a calorimeter. So we are going to use a calorimeter which will help us in the method of mixtures, and I'll be explaining why we use a calorimeter and what is a calorimeter. So we can look at the precautions to minimize. So in this we use a calorimeter. Calorimeter is used in the method of mixtures in the determination of the specific heat capacity. Now, we need to know the following about the calorimeter, that the calorimeter should be number one, that calorimeter or that instrument that we are using, which we are going to have a diagram for, should be number one, highly polished. Now we learned that in heat transfer book 2 that the shiny surfaces are poor emitters of heat. So when we use a highly polished calorimeter, it's to minimize heat loss to the surrounding. So all this that we are having here, the highly polished calorimeter, we are saying is to minimize. This is to minimize heat loss to the surrounding. Make note of that. Then again, the calorimeter number 2 should be heavily lagged. Heavily lagged. We also learned about lagging in heat transfer, where we say that lagging is covering the good conductors of heat with insulators to minimize heat loss. So it is again heavily lagged, again to minimize heat loss. So this one is also to minimize heat loss. And finally, the calorimeter should have, in this case now, the calorimeter should be highly polished, should be heavily lagged, and should have a lint which is a poor conductor of heat. So we can say that it should have a lint. We can talk of an insulator lint. That is a poor conductor of heat. So again, the reason as to why it should have a lint which is a poor conductor of heat is again to minimize heat loss. So this one is again to minimize on heat loss. And that's why we go for the calorimeter, because the calorimeter can be used to minimize heat loss when we are conducting the experiment or this practical on the method of mixtures, because it has the following features. It is highly polished, it is heavily lagged, and it has an insulating lint. So this is how our calorimeter looks like. And this is what we refer to as a calorimeter. It's not a complex instrument. So this is what we have as our calorimeter. It can be a copper calorimeter. It can also be made of aluminium, like mostly the ones we use in the laboratories. The school lamps are made of aluminium. So here we are saying this is now our lagging material. This is the lagging material to minimize the heat loss. So this is the highly polished. We are saying that the calorimeter is highly polished. So this is a highly polished surface. This one is highly polished. Then we are saying that it has a lint. It has a lint. This is the lint, and the lint has two openings, one for inserting the thermometer. This is our thermometer. And two, the lint has an opening also for what we refer to as a stirrer. It is used to stir the content. So this is our thermometer. And this is what we are referring to as our stirrer. So that is what we have for the calorimeter. We have the stirrer, the thermometer, the lagging material is there. We have that as our calorimeter. So this is simply what we are calling the calorimeter. So for example, if we want to determine the specific heat capacity, let's say of a metal block, and maybe in the calorimeter there is water here, then we just come and drop the metal block inside this part here. This is our calorimeter, and we'll be explaining how do we use it to determine the specific heat capacity. So I want you to note that that's the calorimeter. It is used to minimize heat loss to the surrounding when we are conducting that experiment on determination of the specific heat capacity. So this part here is highly polished to minimize heat loss, because we have seen that the polished surfaces or the shiny surfaces are poor emitters and also poor absorbers of heat. Then we have a lagging material here. We use a poor conductor of heat, like the asbestos material is a poor conductor of heat. So it is used again to minimize heat loss. Then we have lint, which is a poor conductor of heat, again to minimize heat loss. So in this calorimeter, we have seen that we have these two openings here, one for the stirrer. A stirrer is just used to stir the content, whatever is inside the calorimeter, and we have a thermometer for checking the temperature of the content.